350,000 wafers a month. Laid flat, that is roughly 25,000 square meters of silicon cycling through process tools every 30 days. About 3.5 soccer pitches of 300mm discs moving in a continuous loop. In late 2021, the equivalent reading for CXMT, the Chinese state-backed memory maker based in Hefei, was roughly 40,000 wafers a month. The delta between those two readings, taken across less than 4 years, is approximately 8 times. This script measures both readings, names the mechanism behind the ramp, sets the current count against Micron's scale, and marks the next dated checkpoint. The unit is wafer starts per month. A wafer start is the moment a blank silicon disk enters the first process step in a fabrication plant. It is the input reading, not the output reading. Yield, node density, and product mix all sit downstream of the count and are measured separately. CXMT does not publish its own monthly figures. The roughly 40,000 wafer starts per month figure for late 2021 is an analyst estimate assembled from equipment import records and supply chain interviews. The roughly 350,000 figure for mid-2025 is an industry tracking estimate drawn from the same methodology, power consumption monitoring, equipment shipment data, and procurement records. Neither is a confirmed company disclosure. The instrument is the best available, and it carries that qualification throughout. The 8 times expansion happened across a period that began, not coincidentally, just before the first major round of United States export controls on advanced semiconductor equipment took effect in October 2022. The controls were designed in part to prevent CXMT from acquiring the lithography and deposition tools it would need to continue scaling. The reading that followed was the opposite of what the restriction projected. State capital that had been distributed across a range of technology investment categories, concentrated with unusual speed into memory manufacturing, once the import route for advanced DRAM was restricted. Fab lines in Hefei were added. Equipment orders were placed with domestic Chinese suppliers and with non-restricted foreign makers whose tools had previously been considered capable but not competitive. The export controls did not hold the count at 40,000. They are, by the instrument's reading, the event most correlated with accelerating it past 350,000. The supply chain reorganization is its own supporting delta. In CXMT's early production lines, the majority of process equipment came from United States and United States allied suppliers, the dominant sources for lithography, etch, and deposition tools at competitive nodes. By mid-2025, the bulk of reported new tool orders for CXMT's expansion lines come from domestic Chinese equipment makers and non-restricted foreign suppliers. That shift happened in under 3 years. The mechanism is direct. The export controls created a forced substitution event. Domestic equipment makers whose tools had previously been benchmarked as not quite competitive suddenly had guaranteed demand at volume. That demand funded iteration cycles those makers would not otherwise have been able to sustain. The controls produced the customer that produced the equipment maturation. A supply chain that was largely Western dependent has reorganized around alternative sources, and the reorganization was funded by the restriction itself, 350,000 wafers per month. The number recurs because it is the current instrument position, and the instrument is what the measurement is. 40,000 then, 350,000 now. 8 times over in under 4 years. The distance left to close against Micron is still a real quantity. Micron's global DRAM capacity spans fabrication plants in the United States, Japan, and Taiwan. At the start of CXMT's ramp, Micron's total reported wafer output across those sites dwarfed the Chinese figure by a margin that was not measurable in the same breath. As of mid-2025, CXMT's roughly 350,000 wafers per month sits at a fraction of Micron's total that is no longer negligible. Significant, but no longer in a different category. The gap has moved from vast to measurable within a single fabrication generation's life cycle. That is the delta on distance. The mechanism behind the closure has 2 components, and the second one matters as much as the first. Micron's capital over the same period was directed primarily toward node transitions, moving up to the most advanced process generations to produce higher density, higher margin chips. It was not expanding starts at mature nodes where CXMT is concentrated. CXMT, by contrast, built volume precisely at the nodes Micron is actively reducing its share of. The closure happens partly because Micron vacated the lower tiers. The gap narrows at the bottom of the product stack, commodity low-power memory for personal computers and mobile devices, while the upper end, high bandwidth memory, and the most advanced mobile memory, remains a separate and wider gap the wafer count does not touch. One instrument, two different stories depending on which tier you are pricing. The node gap is the second instrument and it reads differently from the first. When CXMT entered production in 2021, its process node was roughly 2 full generations behind the leading edge. As of mid-2025, the node gap to Micron's leading process is understood by industry analysts to remain at least 2 full generations. Near zero improvement in relative node position, despite the large capacity ramp. The reason is structural. Scaling wafer starts is a capital allocation problem. You build more fab lines, you order more tools, you hire more process engineers, and the count rises. Shrinking the node is a lithography and process chemistry problem. The extreme ultraviolet lithography machines required to print the most advanced layers are covered by the export restrictions and have not been supplied to CXMT. That embargo created a ceiling that the volume ramp does not touch. The two instruments are measuring different things. The capacity count and the node position are not the same reading, and reporting one as a proxy for the other is a systematic error. The mechanism behind the headline delta is easier to see once you render it at the right scale. A water main shutoff upstream does not drain the reservoir already downstream of the valve. It forces the downstream system to find every alternative inlet it previously ignored: the rainwater collection, the groundwater pump, the neighboring district's overflow pipe, and to build them out faster than it ever would have under normal supply. That is the mechanism here. The export controls were the valve. The 350,000 wafer reading is the reservoir level after the alternative inlets were built. The valve did not drain the count. It built the plumbing that now feeds it. The market share signal is the output reading that follows from the capacity reading, and it is beginning to move. Chinese domestic DRAM production represented a small single-digit share of global DRAM bit output in 2021. That share has grown by multiple analyst estimates as of mid-2025 to a range approaching double digits in the commodity DRAM segment. The estimates are from analyst firms, not official trade data, and they should be read as estimates. The mechanism for why the share growth matters is price. Volume at a mature node, when it crosses a threshold, starts to move spot prices in the tier where that volume sells. CXMT's output does not yet set the global price, but the tier it is selling into, primarily personal computer memory and some mobile memory, is where marginal supply has historically had outsized price impact relative to the volume involved. The instrument is beginning to register in the market it is measuring against. That is a different kind of reading than raw wafer count, and it is the one that Micron's pricing desk watches more closely than the fabrication throughput figure. The margin on all of these readings carries 3 specific corrections. The first is the distance between claim and proof. CXMT does not publish monthly wafer start figures. The roughly 350,000 number is assembled from equipment import records, power consumption tracking, and supply chain interviews by analysts who specialize in semiconductor capacity. It is the best available reading, but it is not a confirmed company disclosure. If CXMT's own figures ever surface and diverge from the estimate, the delta recalculates from that publication date forward. The second correction is the node gap as a ceiling on what the count means. Wafer starts at a mature node do not convert linearly to competitive product against a leading-edge node. A wafer processed at CXMT's current generation yields chips with a different density and, in the applications where density matters most, a different performance envelope than the same wafer processed at Micron's leading generation. The capacity reading flatters CXMT on volume and understates the gap on product sophistication. Both readings are simultaneously true, and the volume figure alone overstates the competitive distance closed. The third correction is yield, which is the missing instrument in this entire measurement. Yield is the fraction of chips on each wafer that pass electrical testing and can be sold. It is not publicly disclosed by any of the parties involved and is not captured in any wafer start estimate available to outside observers. A fabrication plant running 350,000 wafer starts per month at a low yield ships materially fewer functional chips than one running fewer starts at a higher yield. Early generation ramps at nodes a manufacturer has not run at high volume historically carry lower yields than mature, optimized process lines. The wafer start count is the input reading. The functional chip output reading is not available from any public source. The synthesis on all 3 corrections is this. The instrument names a real and large movement in one measurable dimension of DRAM manufacturing. It does not measure node equivalence, yield, or product mix. Read as a trajectory gauge on capacity, it is a reliable reading. Read as a product competitiveness score against Micron's full portfolio, it overstates the case by a meaningful margin. The delta between roughly 40,000 and roughly 350,000 is not a rounding difference. It is a structural shift in where DRAM is manufactured, who manufactures it, and what equipment they use to do it. The restriction that was signed to prevent the ramp is, by the instrument's reading, the event most correlated with accelerating it. The mechanism is not paradoxical once you measure it correctly. Blocking the easy import route concentrated capital on the domestic route until the domestic route became the only route, and then it was funded at a scale the unrestricted version would likely never have reached, because the unrestricted version had no forcing function. The gauge does not call a winner, it records a direction, and the direction has not changed reading since the first control was signed. The next dated reading to watch is the fourth quarter of 2025. The checkpoint is whether CXMT's reported wafer capacity crosses 400,000 per month. If it does, the follow-on question is which tier of Micron's product stack begins to register the pressure first in spot pricing data. That is the instrument check that makes the current reading either matter as a trajectory or require recalibration. It is also the moment when the yield and node data, if any of it surfaces in filings or analyst disclosures, would either confirm or revise the 8 times delta as a meaningful competitive measure rather than a volume figure reported in isolation. If you want to see that reading when it lands, alongside whatever yield and node data surfaces before then, the subscribe button and the notification setting are the only instruments that route it to you when it posts.